Titration is an immensely important kind of methodology in chemistry, especially in A-level chemistry, and it just means an experiment where you have two solutions that you add one to the other until you reach some kind of result, for example a colour change in an indicator or whatever it might be, and you accurately know then the volumes of both solutions at that crucial point, and from that you can calculate something that you're interested in. So what that generally means is that at least one of the solutions you have to know accurately what its concentration is. And so one of the key ideas that you need to be familiar with is the idea of a standard solution, because you may get asked how would you make a standard solution of whatever it might be, and so you need to know what that means. And really it just means a solution whose concentration is accurately known. But at A-level, more specifically, that means that it has accurately known concentration because you have a measured mass of pure substance and you dissolve it to make an accurately measured volume of solution. So that's what a standard solution is in as far as we're concerned in A-level chemistry. So an accurately measured volume. So you need to be able to describe the sort of practical aspects of doing that. In other words, talking about the right kind of equipment and so on. So the first thing you're going to have to do is to calculate the mass needed to give you the volume that you want. So calculate the mass required. So let's look at an example of that. So suppose we want to make 250 cm cubed of 0.2 mole per dm cubed sodium hydroxide, NaOH. So obviously what we've got to do is to calculate how many moles of sodium hydroxide we need, then we can turn that into a mass, and then we can measure out that mass. So we get moles, here's concentration times volume in dm cubed, which is 0.200 times 250 cm cubed. Remember, you have to divide by 1000, so that's 0.25 dm cubed, which is 0.05 moles. And then we turn that into a mass. Here's moles times mR, which is 0.05 times 40.0 is the mR of sodium hydroxide, which is 2.00 grams. Okay, so that's the first step that you're always going to have to go through, and then the second step is obviously to weigh that amount out. And you should specify how you're going to do that. So weigh using an electronic balance. Now what comes next is not that you then just simply dissolve it in water, in 250 cm cubed of water, because it's not as simple as that. If you add 250 cm cubed of water to that amount of sodium hydroxide, the volume you end up with won't be exactly 250 cm cubed, because the volume changes a little bit when you dissolve things. Often we ignore that, but when you're trying to make up an accurate solution, a solution of accurately known concentration, you can't ignore it. So the crucial thing is that you don't add 250 cm cubed of water. So what you do is dissolve it in a smaller amount than that. So there's no fixed amount here, but if you just specify an amount that's significantly less than 250, so let's say dissolve in 100 cm cubed of distilled water. And always in these practical questions, the how would you do this kind of question, if they want practical details, you should specify the apparatus. So in a let's say 250 cm cube beaker, And that may seem a bit trivial, and you would only do that in questions where it clearly wants you to specify the practical details. Okay, so you dissolve in 100 cm cubed. Specify distilled water. Don't just say water. I mean, it may seem obvious to you that you know you're not going to use pond water, but it's not obvious to them. So you specify, you know, the pure stuff, distilled water, in a and specify the size of the beaker. Because 100 cm cube distilled water in a 100 cm cube beaker is not going to work. You're not going to be able to stir it round without spilling it. So specify a sensible size. Once you've dissolved it, what you then do is transfer to a 250 cm cubed volumetric flask. Now you need to recognise and possibly even be able to draw a volumetric flask. So what it looks like is that it has a long stem like that and then a sort of bulb at the bottom with a flat base. So it looks like that sort of shape, and it has a stopper that can go in the top like that. And crucially, what it has is a graduation line on there. So if it was a 250 cm cubed volumetric, that would be the 250 cm cubed line on there. And that's very accurately measured. It's not like the markings you get on a beaker or a conical flask, which are just rough guidelines. This has been accurately measured so that it really is 250 cm cubed when you get it onto that line. So the idea is that you're going to add your solution into there. So, you know, it's only 100 cm cubed, so it's going to come to sort of here or something. And then you're going to add more distilled water to bring it up to the line. And again, you need to know how it works with these lines, because if you've ever looked at water in a tube, and you all have because you've done this with burettes and things, you know that the water tends to cling to the sides of the tube. And so the top of the water won't actually be dead flat on there. What it will look like is something a bit like this. Okay, so the surface of the water is curved because the water molecules tend to cling to the glass and climb up the sides a little bit. That's called a meniscus, that curved surface there. And the rule is that the bottom of the meniscus should sit on the line. That's when you've got exactly 250 cm cubed. So you've got to remember that that's the way it works, because quite often they give you questions either with one of these or with a pipette where you get the same issue, and they ask you, you know, what's the correct way to measure it? You know, is it like that, or is it sort of like that, or is it like this? And the answer is that one, not those. Okay, so that's an important principle. So you're going to transfer to a 250 cm cubed volumetric flask, and you're going to add water, specify distilled water again. Up to the 250 cm cube mark. Okay, so we've now added water, but of course what's going to happen is it's not really going to be mixed. Not very well anyway, so you're going to have mainly your concentrated sodium hydroxide solution at the bottom and mainly water on the top. So crucially, what you then do in step 5 is you put the top on and you invert repeatedly to mix. So what that means is, you know, if this is your flask, you put the stopper on the top, put your thumb on it, and you turn it upside down and back several times. Lots of times actually like that, to make sure it's thoroughly mixed. And they're going to expect you to say that. So don't just say mix, because they'll say, well, how are you going to do that? So invert repeatedly to mix. And that's a good standard recipe for making a standard solution.